Alright guys, because this is so important, I decided to dedicate an entire video to it. We're going to talk about constructors and destructors and what they are. They are a brand new concept to C++, coming from C, and there's really nothing like them in C. I mean, I guess there is, but they were just regular functions before. So let me first talk about what they are. For this example, I'm going to create a class, which I've already kind of got it started on, called int_array. And the whole point of this class is basically going to be to provide an encapsulation or a wrapper, as we call it, around an integer array or an array of integers. So that we don't have to, if we want to create a dynamic array on the fly, that we don't have to call malloc and free or new and delete ourselves. We can just do it. So what would this class look like? How would I like to use it? Let's just pretend it existed. So I've declared it up here. I basically have int array a, right? And what would I like to be able to do with it? Well, for starters, I'd like to be able to tell it what its size is. So maybe I would have something like a.setSize. And then, I'd like to be able to use it. So maybe I'd like to be able to have a.get. And maybe this would be like the nth element of the array. And that would return an integer, right? Maybe it'd be something like that. So the only thing that's kind of frustrating is maybe we only want to be able to set the size of the array once, and ideally we'd like to have the size of the array known immediately when it's declared, and maybe have that remain constant throughout the life of the entire array. That's possible. I'm going to put this in a function just because I want to keep this scope of this thing limited. Okay. So basically this code's going to work, but A doesn't do anything. It's an empty class right now. So let's start by introducing the concept of the constructor and what that is. So as you guys know, you can have functions in here. For example, I think I called that get. So you can have functions in here like this. What constructors are functions that essentially have no return value. There's no void over here. That have the exact same name as the class and can take 0 or more arguments. So, like I said, no return value. So it looks just like this. And what this basically does is it says, call this function immediately when the object is created, once for every new object. So it's a member function. And basically, the way you would provide the declaration or the implementation of the function would look like this. Note, there's no void here. There's no return value at all. You can't return anything out of a constructor. It's assumed that the constructor constructs the object, and the return value is kind of implicit. I'm also just going to provide really quickly for now, just to get this to compile. So essentially, what is a constructor? A constructor is something that sole purpose is to provide the base initialization or the default initialization for the entire class. Another way to explain this is, remember I've declared one of these up here, so I've already got one. If I just print out in here, new int array, looks like my syntax highlighting is a little stupid right now, but that's fine. New int array, %p, which is for pointer, and this basically will print out this line every single time we create one of these arrays, and we should see it show up in the console when we did. So basically what this is saying is, right here in main, when we create one of these things, the constructor is ran immediately at this line. By the time the next line is ran, the constructor's already been completed. And that's how this code gets printed. If I were to comment this out, we would obviously see that there was no call to any constructor at all. So that's essentially what a constructor is, but obviously there's a lot more to it. When you have a constructor that takes no arguments, an empty parameter list, it's considered or called the default constructor, meaning this is the constructor that's ran in cases where there is no initialization parameters provided to the construction of the object. Much like function overloading, constructors can be overloaded to take as many arguments as you want. You can take different code paths based off of the arguments to many constructors. The way to put this into explanation or into example is if I wanted to have int array and pass in n, where n is my desired size of the array that I'm declaring, I would go ahead and declare it like this, And then when I implement the thing, it would look like so. And what I can do in this case is I can basically say, you know what, they wanted a new integer array, but they wanted to provide a size. Okay. So how do you call this? Well, the easiest way to call this, well really the simplest way to call it when you declare an int array like this, is you basically just put the parentheses right after the variable. And this looks very weird to someone who's never seen it before, but basically this is a constructor call here. As a matter of fact, you could even do this if you wanted to imply calling the default constructor. It's just not always done. But putting this argument right after immediately tells it that I'm calling this function, and when I run it, you will see that we got into the second constructor call, which basically says there's a new integer array of size 100. So that's essentially statically allocated construction calls, or statically allocated constructors. In other words, when you declare a class like this is how you call and define the constructor that occurs when that class object is created. So let's talk a little bit about the default constructor before I move on. There are some cases where you don't want this default constructor to be available. This is one of those. For example, what does it mean to declare an integer array that doesn't have a size provided? It doesn't make any sense. If I were to comment this out, and comment this out as well, the question is, would I still be able to declare the object like this? And the answer is no. Once you provide at least one constructor, if that constructor is not the default constructor and you don't provide an explicit default constructor, the default constructor no longer becomes available. And it's basically a way for you to design this object to tell the user, you know what, you can't use this constructor this way. You have to provide or use one of the provided constructors. In other words, we only want you to be able to create one of these objects with an initialization parameter, which is the number of elements you want in the array you're going to make, or something specific. It's required to initialize this object. So that's what that error means. So once again, I'm going to restore it to the way it should be, which is we're creating an array of size 100, and it works. So let's provide a quick initialization for this. Now this is going to look a little nuts to people that have never seen the C tutorial series before, but to those who have, it should look very familiar. I'm basically going to provide in the private data members of the class a data backing, which is a pointer to int, and I'm basically going to initialize this pointer when I create the array. So it's basically going to look something like this. Malloc size of int times n. This creates a dynamic array under the hood of n integers. And because C++ is anal, I'm probably going to have to cast this to return value to int to make sure it compiles. So this basically allows me to say that when the integer array is constructed, inside the constructor I provide any initialization the class needs. In this case, I need a data array, dynamic block of memory to store my integers. And you can probably guess now the get call was basically just going to return data at index. It has a problem. So like I said in C++, or maybe I didn't, you need to include malloc.h to use malloc. Okay, so in C++ you have to include standard lib.h to use malloc. So what we have here basically is a construction of an array and the ability to get an array in any given index. Now there's something I glossed over here that's very important. You notice there's nowhere in this program that has the corresponding call to free for malloc, which is a disaster in the sense that every time we create one of these arrays, as many as we want, we essentially are leaking the memory because we're never returning, or we're never getting a chance to call free. So when's the ideal time to call free? Ideally, since the memory management is done automatically when we create the object or when the constructor is called, ideally we'd like to have the memory be freed the minute A goes out of scope. When you hit this brace, basically when you no longer need A or B anymore, the associated memory should be freed. And that's where the concept of the destructor is introduced. It's basically the opposite of a constructor. It is ran the minute the object is destroyed or when it goes out of scope. And the advantage of the destructor is it allows you to make any management or any kind of deinitialization that you need for your class automatic. I will also mention that you can provide, it's not allowed to provide any arguments to a destructor. It's only 0 arguments or an empty parameter list. So you can guess what we're going to do in this case. We're just going to free data. So allocation, deallocation happens on construction and destruction. What we should see here is 2 constructor calls and 2 destructor calls. I always forget to put \n after all these years. So we see as we have 2 constructor calls and then 2 destructor calls. So we're sure that the memory is getting freed and there are no more memory leaks. And that's basically what a constructor provides for you. It's very important that if you do any work inside, you don't always, constructors and destructors are optional. You don't have to provide a destructor, as I was showing before. But it's very important that if you do any kind of initialization in your constructor that needs to be undone or freed in your destructor, that you provide a destructor to do that. So basically, we have that working now. That's what a destructor looks like, and this is an example of how one works. Our simple class essentially is almost done. There are a couple things I want to talk about, though. So because we're wrapping an array in this class, I'd like to provide a set or two if I can. So let me just do that real quick. Void set int index int value. This should be rather self-explanatory as I'm writing it here. Basically, I'm just providing a setter for the integer array at a given index. There we go. All right, so let me just quickly give an example of how I might use my array. So maybe I want to do for int I equals 0, I less than 100, I plus plus, and maybe I want to do something dumb like saying a.set index I to value I, or in this case maybe I times 2. So every ith index has I times 2 in there. And then maybe I want to just quickly access one of them to do like, printf %d a.get the 10th index, which would print out something like 20, and it does. Notice that this happens before the destruction. So we have the construction of the objects, I use the class, and then when I no longer need them, the destructor occurs when the function that uses them returns. If I was to put this stuff directly in main, the destructor would still get called directly after return 0, basically whenever the object goes out of scope. So this is an example of using my integer array class, which helps me declare dynamic arrays, but without having to worry about whether or not the memory is freed, because if the class is written properly, everything just kind of works. Where it gets rather interesting, however, is if I want to provide a safety mechanism that you would never be able to provide if you were using the arrays directly from C code. So what would happen if I called something nuts like a.get 10,000, 100,000? Well, I get -1 here, but in reality, this is an unsafe memory access. The program really should crash when I do this. And sometimes it will, sometimes it won't. In this case, I'm getting wild memory. This is a dangerous thing to do. And it's really dangerous in the sense that sometimes, like we just saw, it won't even crash your program when it should. So what if we could trade some of the efficiency of directly accessing memory for the safety of ensuring that we don't do anything wrong? This gets a little out of the scope of what the video is supposed to be about, which is just constructors and destructors, but I don't want to leave this out. Essentially what I can do here is I can write a private function, meaning that we're not supposed to call it from outside of the class. And basically it can be called safety check. And what safety check will do is basically return a Boolean to tell me whether or not a given index is safe to access. And I'm going to implement that just like this. Oops, looks like we have a problem. Looks like we don't know the size of the array because I didn't store it. Well, that's easy enough to fix. I basically can put size in here as a data member, and then when the constructor is ran, I basically can store it just like that. So we have our size. Ideally, this would probably be a size t, so I'm going to go ahead and upgrade that to size t. That just tells me that it can be very, very large number. It's typically a 64-bit integer. So now that we have our size, we can go back here and ensure that when safety check is called, the index is at least less than size. Just running this code to make sure it compiles. So utilizing our own safety check method, basically what we can do here is we can say any getter that just tries to access something that is not passing our safety check will get a value of 0, which is kind of a safe 0. And any setter that does not pass the safety check won't set the value at all and will be a no-op. So our wild memory that's being accessed there should immediately be 0 now, and it is. And we can be sure that we're not crashing the program because the safety check no longer allows us to access memory that we shouldn't. So this is my brief example of what a constructor call is. I'm going to elaborate more on some more fancy things you could do with constructors and destructors as the series goes on, but I at least wanted to provide this introductory video to explain to you guys the concept and how it works. Destructors. There's just one more type of destructor or constructor that I'd like to teach you guys about, and this is when it starts to become rather obvious why C++ is such a complicated and difficult language to learn, simply because there's all these exceptions and rules about things that behave differently from the way they look and how you would expect. And this is definitely one of those cases, so I'm going to try to go slow here and avoid confusing you guys because this can be very unusual the first time you learn it. So first off, as you guys know, when you assign one variable to another, or when you pass another variable as an argument to a function, that variable can either be passed in by reference or by value. And as you also know, when you are copying structs or classes without any specific code to tell you how to copy that object, the internal data structures of the class might get messed up. For example, if I was to naively set one integer array equal to another, it would compile, but the data pointer would essentially get set equal to the data pointer from the other integer array, causing two references to the same block of memory, and then the destructor would free both of them, and it would crash, and the entire computer would catch on fire, and a car would come to your house and kill you. But you don't want that to happen. So let me teach you about copy constructors so we can avoid such things. So first let me show you what a copy constructor looks like syntactically, and then let me show you how it's called. So here's a regular default constructor, as I told you about before. What a copy constructor looks like is basically it is the same syntax as a constructor, but you pass in one argument, which is usually a constant reference of the object that you are interested in making a copy of. You can call this anything. I'm just going to call it R for array. And that's basically the syntax of the copy constructor. I'm going to put this header on the left here. So when you're implementing the copy constructor, as you guys probably can already guess, the idea is to make sure that the internal data of your class is consistent with what would be the result of a copy operation done. So in this case, basically what I'm doing is I'm creating a brand new int array such that it contains a complete copy of all the data that is inside the argument passed in, which is called R. So the way I'm going to do that is first I'm going to basically create, as if I was running the constructor, the array and the size variable and initialize those. However, the size is going to come from r.size. Now you're immediately going to notice that since size is a private variable, you might be wondering how I have access to somebody else's size. Well, it just so happens that int_array as a class inside its methods has access to any, not just its own, private members of any other int_array type. So that's why I'm able to break inside of this private member here, because I should know how to treat those variables. I am the class. Data essentially, yes, should contain another malloc call, which is basically size of int times size. But we're not done. We need to make a call to memcopy here. Yeah, we need to make a call to memcopy such that the value on the left, or myself, is a copy of the array that's passed in as an arguments data. And of course, this is the same size of int times size elements. So that's essentially what a copy constructor looks like, and if I was to run this, there'd be a problem. I believe I have to include string.h, not C++ string, to get access to memcopy. It's kind of part of that header. So I did that, and that fixed that problem. So basically what we have here, if we go back to main, let me show you how to take utilization of this copy construction thing. So suppose we wanted to create another integer array c, which was a copy of a, right? So right now we're printing out a, and I'd like to make a copy of a. Well, the way that that's done using the copy constructor syntax is you basically say int array c which is a copy, and then A. And remember, A is passed in by reference parameter, so I don't need to put the address of it, but it's not copied in when the function arguments are made. Just because I want to be thorough here, I'm also going to put a little printf here to let me know that I'm inside the copy. Basically, I'm making note of the fact that I'm copying array into this. There's that. So when I do this, we should see in the printout that a copy constructor call was made, and it was. And what's really neat about this is now we have 3 deallocs. The third one is the 9688 object, which basically corresponds to the copy. So we have 3 mallocs, 3 frees, everything's consistent, everything's fine. This is fine, and syntactically you'll see people do this occasionally if they want to be explicit. This is where it gets confusing. C++ realized that most people don't want to write code that looks like this. It's ugly, and it's not always clear what you're doing. So what they wanted to basically allow you to do is provide initialization on construction using a familiar syntax, which is probably going to look very familiar to you when I write it out. Believe it or not, this actually is the same thing as the above call. This is a shorthand, or maybe longhand, if you will, of a constructor copy call, or copy constructor initialization. You'll notice here that when I run this, the code behaves exactly the same. However, this syntax is much more familiar. Declare C and set it equal to A. It doesn't go ahead and call the default constructor first for no reason, just to immediately destroy the data and set it to A. That wouldn't make any sense, and the compiler knows that wouldn't be efficient. C exists immediately only one time, which is initialized with A as the argument to have its data copied into. So those are copy constructors, and it's really important for me to cover this little edge case because in the next video, when I start talking about operator overloading, that's when it starts getting really complicated. So those are constructors as a whole. I hope you guys were able to follow. And as usual, thanks for watching, and the next video should be coming right up.